Hi guys, this video will perform 5 practical steps to secure and monitor Red Hat Linux. First, we will update critical severity updates, encrypt this with LUKS, restrict access or USB drive using USBGuard, monitor events using Audit, detecting unauthorized file modifications with AIDE. Let's see how many critical severity updates do we have. DNF update info -- security grep critical. We have 17 critical security notice. Let's determine how many security related packages are available for this. DNF -- security list updates. These are the available updates we have. Let us list down and identify the critical updates. DNF update info list update pipe grep -I critical. Let's view the synopsis of the critical RHSA-2024:1484. DNF update info RHSA-2024:1484. From here, we are interested with CVE-2023-5388. DNF update info list -CVE CVE-2023-5388. These are the packages to be installed. Let us update the package. DNF update -CVE CVE-2023-5388. Let us run the critical updates again. DNF update info -- security pipe grep -I critical. There are still one critical security notice. Let us update this until there is no more critical updates. Let's view the current partition and see which disk can be used. We will use NVMe0N2 partition. Fix this /dev/NVMe0N2. Let's view the partition. We create a new partition, primary partition, all the defaults, and write. Review the partition we just created is NVMe0N2P1. Encrypt the partition with CRYPT setup, LUKS format /dev/NVMe0N2P1. Enter capital yes to proceed. Enter BLK ID pipe grep LUKS to check that the format has been done. Before we open the encrypted disk, let's look at the /dev/mapper. Now this is a default mapper list. Crypto setup LUKS open /dev/NVMe-N2P1 and encrypted name, encrypted part. Take note that this encrypted part can be any name you like. Enter the password we have set previously. When we list down, you can see that our encrypted part is map. After the partition is mapped, create a XFS file system using mkfs.xfs /dev/mapper/encrypt part. Create an encrypted directory mkdir/encrypted. Now we mount the encrypted folder. Mount -t xfs /dev/mapper/encrypted part/encrypted. Then to check that it is mounted correctly, we mount with a pipe grep /encrypted. Create a testing file inside the encrypted folder. Then we unmount the encrypted folder. Then we lock the LUKS encrypted partition by closing the encrypted partition. When we list out the /dev mapper is no longer mapped. We can always reopen the LUKS encrypted partition with another name, like for example using the testing, and the same file will still be there. Finally, unmount the encrypted folder and close the LUKS partition testing. Let us install USBGuard. DNF lists USBGuard, USB utilities, and use these two. The package are found, then we install the USBGuard, USB utilities, and use these two. Enable USBGuard system CTL, enable USBGuard -- now. List the device that we're gonna use. USBGuard list - devices. List the current USBGuard rules using USBGuard list - rules. Generate the USBGuard policy using USBGuard generate - policy. Save to /etc/USBGuard /rules.conf. After that, restart USBGuard services. Using USBGuard list - devices. By default, our USB drive are blocked with the item number 12. We issue a USBGuard allow - device item number 12 to allow access. When we use USBGuard list - devices, you can see now is allowed on item number 12. Since this allow is temporary, when the system reboot, it will go back to block. So we need to allow persistent by using USBGuard allow - device -p item number 12. USBGuard list - devices again, and this item number 12 will be persistently allowed. Let us install Audit. DNF list Audit. These are the packages to be installed. So DNF install -y Audit. This will install Audit. It's already installed. Check the Audit services to ensure it's running. Run a rpn-qc to find the configuration file of Audit. This is the configuration file I'm gonna use. bin/etc/audit/audit d.conf. We need to change a few parameters here. Log format is enrich. Flash equal to incremental ascent. Frequency 50, and name format we're going to change to host name. Save the file and restart the services. Install the Audit service plugin. DNF install -y audispd -plugins. We find the configuration file of the service plugin rpn-qc audispd -plugins. This is the configuration file we are interested in. Edit this plugin configuration file and change the active to yes. The second file that we are going to edit is audisp-remote.conf. Edit the file, go to remote_server, change the IP address of server B, which is 10.80.194.14. Restart the Audit services. Now go to server B, edit /etc/audit/audit d.conf file. Go to this line, remove the pound from tcp_listen_port equal to 60. List the firewall to see if port 60 are allowed. Add a permanent firewall entry to port 60 TCP. Reload the firewall and list all the firewall ports again to confirm that port 60 TCP is entered. Restart the Audit services. We're going to server B, look for the audit log. We want to truncate the logs to make the logs clear so that you can see the latest logs. We do a test by logging to server A. From the user, do a sudo to root and exit the server. From server B, do a grep server A audit.logs. We can see that the logs are sending and recorded in server B. Let's install AIDE. Do a DNF list AIDE. There is one package to be installed. We do a DNF install -y AIDE to install. Locate the AIDE configuration file using rpm-qc AIDE. Perform a backup of the AIDE configuration file. Edit the /etc/aide.con file. From the file, search the word starting with /. Do a capital V as visual mode, capital G to select all, D to delete. Insert a line /etc tab content _ex. Then we initialize the AIDE database by doing an AIDE -init. A new database is created under /var/lib/aide/aide.db.new.gz. So we rename this file and remove the new. We do a AIDE --check to determine the status of the file system. The file systems looks okay, nothing has changed. We modify the /etc/shadow file, currently is 000 permission to 644. Run the AIDE -check and AIDE reports there's a changes of the file of the /etc/shadow file. Let's change the /etc/shadow file back to the original permission and run the AIDE -check again. The AIDE will report that all the file systems looks okay.